Hallo und herzlich willkommen auf der Industrie.forward EXPO. Ich bin Dana Neiske vom Publish Industry Verlag und moderiere Sie heute durch den Vortrag Machines Updating Themselves. Dafür bin ich natürlich nicht alleine. Bei mir auf der Industrial Solution Stage begrüßen darf ich Ossi Talvitie, Chairman of the Board, Node. Hi, nice of you to be here today.
Thank you, nice to be here.
So, and that's it from me. Ossi, the stage is yours.
Assuming everybody can now see my screen and our company name and a slogan. I am representing a company called Node, and we have quite bold statement or slogan now there in the first slide, liberating machinery. I have chosen that by reason. It tells also a little bit of the background of our company. I am, and we are all founders of the company coming from the industrial automation world, meaning that we have background in companies such as Siemens, Beckhoff, B&R, ABB, and so on. And during those years of working with, specifically with machine builders, industrial machine builders, and trying to help them to utilize best possible solutions with that technology available in the market, we have witnessed with our own eyes very often many kind of boundaries and limitations that the operational technology devices, such as industrial automation devices, unfortunately have. Some of these boundaries are for the fact that it has been difficult or impossible to do better, and some of them have been done on purpose, unfortunately. Today, I'm trying to draw a picture that we as a company, we have taking our goal to be to free industrial machine builders for any such boundaries, and meaning that we want to offer a technology that allows industrial machine builders, system integrators, and similar players working in the industrial networks to use same or similar tools as the IT sector is doing, because there are a lot of things in the IT sector that we have to admit that it is ahead of us when it comes to the openness, flexibility, and independency of the system. Our product is a software solution, software-only solution, so we don't have any physical devices. That is called Nuke's Cloud, and the toolkit is designed for machine builders and in other industrial technology companies to utilize IT technologies and the benefits and best practices of the IT technologies within the OT network. It is fully built on Docker ecosystem, and I will get back to Docker a little bit later, but it is a very important part of my presentation today, that why Docker and what it gives to us when we utilize such solutions. But I go to those details a little bit later. Before I can go to an actual headline of today, industrial machines updating themselves, I need to show the architecture picture, because it is next to impossible to follow my presentation if I have not explained first how the infrastructure works when it comes to our tool. Our tool is basically a combination of two different applications, one that we call an edge app and one that we call a cloud app. The cloud app could be also easily be called something like central app. Why I want to mention this is that even though this is a cloud app by name, it doesn't mean that it needs to be a cloud, but it is the one that is so-called central part of, or the central piece of our software. So it's typically either in a cloud or other server. Technically, it can be in the factory or even in the same device as the edge app. But the idea of the cloud app is that it is that piece which is combining all the physical sites for different operations. And the physical sites are then controlled by what we call an edge app. Edge app is also a Docker container, and it's a full independent, intelligent piece of software, meaning that it fully controls the local operations. It doesn't need connection to cloud app for any of its operations as such, but it gets the configurations and commands from it when there is some change or new order needed. However, in the local network, Edge app can communicate with any device. It can take control of the Docker layer and also Linux root layer of the devices, and it can be then integrated in the local network to any software or other solutions within the network. And this is important to explain for the later parts of this presentation. If we look at this picture now, this is the basic architecture. And if we go a little bit deeper to the case industrial machines updating themselves, we need to add a couple of pictures which are now no longer parts of our software, but something that is typically around our solution. So first picture that I draw is that, like I explained, that the local Edge app can be combined with other local applications over REST APIs. The same can be done with the cloud app. And that means that if the cloud app needs to deliver either something that Edge app have gathered from the network data gathering or something like that to other system, it can be done over an API. Or if something needs to be distributed back to the Edge app, it can also be done so that as long as it's available in the cloud app environment, it can be then further going to local networks. So how would this work? Let's say that we have here a BNR PLC, and we would like to have a new software version of the BNR PLC delivered to this particular device, including operating system, for example, update of operating system. And we as an industrial machine builder may have then here a version handling system. Git is as an example here, that we have full control of what software we should have in different sites and in different devices within those different sites. So we have under control our version handling of our softwares in the first place. Then we can configure individual Edge apps around the world. That this Edge app knows that from this location in the cloud, he needs to look if there is a software version, and that software belongs to this particular device in his own network. Meaning that if he sees that here is the version 15 and here's the version 14, he can pick it up, and then further we can get it to the API level of the Edge app. And from there, we can even build a separate piece of software which even updates the PLC itself. Newcomer offers these tech apps to most common PLC manufacturers such as BNR, Beckhoff, Siemens, so on. So meaning that we can even go so far that here we get it from the Git all the way to the PLC itself. It reboots and runs with the new software version. Of course, in many or even most of the cases, you cannot just push a new software version in, even if you build to your machine some kind of an acceptance on the HMI panel that, hey, I have a new software version, do you want to accept it or not? Yes, or I will update myself next time I'm in the idle mode, or however you want to build it. But there are many applications where you actually need to be on site to do this, obviously, because the security and other issues, the service technician needs to look that it works like it should. But still, the fact that you distribute the softwares globally with one press of a button gives you a lot of benefits when it comes to human errors and unnecessary traveling and all these kind of things. So it improves the process significantly anyhow. And one last thing about this pipeline is that it can be configured in any way. It can be either so that you have in the Git version, in the Git you have one version that is going to 500 different sites, or you can have, as long as your version handling is under control, you can have that you have here 10 different softwares, and then only a couple of sites are picking them. So it's one-to-many or many-to-many relation. All this is obviously possible to do. And it's not only software versions of the PLCs that this technology allows us to distribute. It can be other data or file-based things like recipes, work orders, but it can also be full-blown softwares within the Docker container, for example, meaning that we can integrate ourselves to Docker registry and we can distribute other Docker softwares. We can then in the cloud control the local Docker layers, meaning that we can enable, disable, add, remove, and so on, different kind of softwares within the network. And as I told you earlier, the Edge app also can control the root levels of the Linux devices, meaning that we can even update the Linux operating system and do other security updates that are needed to keep the system overall secure. So this was technical background explanation of the actual case that I was today planning to show and explain, and that is industrial machines updating themselves. Now, we are working, or our customers are working with our tool in many such projects at the moment where we are trying to do something that has been everyday thing for us as a consumers for a long, long time. And also in the IT world has been everyday thing that we all know and we are used to. So something like this. You have your laptop saying that I need to update myself, the latest security updates. Next time you shut me down, I will update myself, or my phone is doing the same. Even my vacuum cleaner today is getting updates from internet. So how is it even possible then that industrial machines, we basically are only starting this path at the moment? Well, the reason is quite obvious. We have not really utilized the technology like Docker and other modern IT technologies within the OT world yet. And that's which is like the core of Nuke's existence. This is why we exist, that we try to make this everyday manner here. Of course, it's much more complicated and difficult here because the tools doesn't exist. Now we are a tool, and now it's no longer that complicated like it would be by doing this from the scratch yourself. So, making the same picture, a little bit just in a different form, we have the version handling system, we have the API, and we have the cloud app, and then we have the local Edge app, and we have the tech application, and then we have the control system. So we can have a version handling system where we are putting the software distributed, one of Nuke's tech apps, maybe giving it further, or in many cases, we have, for example, customers who have built the control system themselves, and they have done the tech app also themselves. And like I said, we can add a private Docker registry. Now, if we think about the case, I think that many of you already figured out why would we want to update the PLC software. For example, the use cases I have seen is that you are creating some kind of a process, and you can make the process use, for example, less energy doing the same job. You can have, for example, a system working faster, or anything else which is requiring a change to your real-time operations of your machine software. Then we are talking about the PLC software. Now, why are we then talking about Docker? Why are we combining Docker registry and the local Docker layer? Now, later in this presentation, I will very briefly explain a little bit of the history of Docker and so on, but I just at this point want to take one small peek to that already. If you don't know what Docker is, I bet that most of you do, but I will still explain that from my point of view, the most important thing what Docker did, why it exploded so big, was that Docker and other container technologies virtualized the operating system of the software. So that means that back in the days, you needed to have software, you needed to take a lot of things into consideration, because for the software to run, it needs more than just the code. It needs certain libraries, it needs certain things that the operating system offers it, and so on and so on. So that's why we have had this, that traditionally the softwares, especially in the operational technology devices, has been maybe different versions, if it's this Linux or that Windows version, and so on and so on. So that's been very complicated to do any updating when you always need to take very much into consideration that, okay, what operating system version I have. And this is still partly a problem. But in the Docker and other container technologies, we have that virtualized. So it means that it's a virtual layer within the container, so it works as a full-blown software in any environment. And this allows you as a machine builder to do certain tasks that are not like real-time solutions, such as visualizations or optimization softwares and others. Those softwares that you have already done, Dockerize them, then you can distribute them, and you can much more easily and freely run them in any environment. So My customers, I can see, for example, doing a lot of different kind of user interface tools, different kind of maintenance tools, and more machine learning algorithms, for example, constantly learning from the process. Let's take an example of a logistical device where you have, or logistical system where you have picking different kind of parts from different locations. You have a machine learning algorithm constantly following what the machine is doing, and then understanding that, hey, you are not doing an optimal order of your products because this product goes much more often than this product. And then this kind of software can be a real business for the machine builder and technology provider. Dockerize it, distribute it, release new versions of it, teach it further, make it constantly better. These kind of applications I see when it comes to Docker. Moving a little bit forward, what this technology allows me to do is that everything I do in a cloud, so central control, I can also do in the local network. Now, I said in the beginning of the presentation that typically I have one cloud app which controls all the local edge apps. This is true, but there are many places where you need those capabilities also at the local end. For example, you need to have some local pipelines. You have, for example, hundreds of robots in the factory, and you want to have a separate locally controllable pipeline for those robot updates, or just to distribute the softwares within the local network, and you want to have that fully controlled in the local network instead of the global one, because it's a local tool. Even this I have seen. And further, we have seen a lot where we are collecting the data and creating the databases and the tools to control the databases, which are the features of our cloud app, are needed in local. For any reason, one of them could be that one of our Docker containers that we just distributed needs certain collected data from the control system, the certain database structure, and then we can offer this also local network to these applications or any other application. We can even go so far that we use the centralized cloud app as a master to the local cloud apps, meaning that you can then, if you have these local applications that are built on top of the Nuke Node app, can be then having a master app in the cloud. So even though they are totally controllable and usable in the local network, there are certain settings and new features of that particular app can be distributed on the cloud connection. That is then what could be this kind of a use case. For example, ships. We have a application that we are building in Azure or whatever, and then our actual installed base is sailing around the world without internet. And you are doing a lot here, and then when one of these guys gets to the shore, we can send a couple of Docker packages to it. We can couple of updates for the operating system, for the control system, but we can also then update the local cloud and other applications while we have the internet. So it allows us to operate in the systems where we are not constantly around the internet connection, because all these pieces of software are Docker containers, meaning that they're independently working units, meaning that they don't need a connection to internet constantly, which is a very important part of our system. Now, last 2 minutes of my presentation, I would like to show two things as a background information, a little bit, that why these kind of things that we are showing are not yet everyday business in the industrial world, and why companies, when they meet us for the first time, are very typically asking us that why is nobody else doing this? I mean, there is a lot of companies basically doing this as a multi-million software project, but why is nobody else doing this as a tool? Well, there are certain reasons for that. It requires a lot of IT knowledge, but it also requires a lot of OT knowledge, and we have both. But it also is something that has been technically possible for the relatively short time. And I think that it all goes down that internet technology have taken so huge leaps in the last 10 years that we can now utilize that leap in the OT world. So if we look at the internet, everybody in this room definitely knows what internet is. It's the devices connected to each other, and they are using TCP/IP protocol to transfer data or transfer information between each other. And typically these devices have been computers or other so-called IT devices. Now for the last 10 years or so, we have been hearing a lot of Internet of Things saying that, okay, we make this even bigger thing when all the OT type of operational technology type of devices are also connected using same technology to this network. This is true. However, the use cases we have been doing around the Internet of Things are by far behind what we have been seeing in the Internet world. So if we look at the history of the Internet a little bit, I think that we are in the data transfer level almost. So we are 30, 40 years back maybe, if we look many of the Internet in so-called Internet of Things applications as of today. I think that World Wide Web, but especially the social media, exploded the need of certain technologies in the IT world. Social media and other such applications, we are talking about pieces of software where we have hundreds of millions or even billions of users, huge amount of data. We are developing them in around the world. Every bit and piece and button in your Facebook, for example, is a separate software, what we call a microservice, because otherwise it would be impossible to handle all that mass and all that update and all that that deployment and update processes what such a massive system requires. Now, a very big fleet of installed base of an industrial company is also very complicated of a network. So we obviously should use those best practices there. And as late as 2013, Docker was founded. So we're talking about few years that we have had such technology that can totally do things differently than they were used to do. And like I said earlier, the virtualization of the operating system level of the software is the most important piece of that story. It means that when everything is in the container, it gives you full independency of operating system, hardware, infrastructure, technology, whatever. So it also goes back to our tool. You can run it in so that we host it for you in the cloud or private server. You can run it yourself in your own Azure. You can run it in your own factory. You can even run it in the IPC, or in some test cases, we have seen it to be run even the Raspberry Pi. So that means that in many cases, the utilization of our tool is doing something that we don't even know what the customer is doing. We just sell them the license keys. So it gives you the full freedom to operate in any environment. It gives you full freedom to choose your automation platform, all the devices within it. You can use any technology, any machine learning technology, any code base, so on and so on and so on. As long as it's a Docker compliant technology, we can get all these benefits and we can combine it with all the know-how and benefits what you can build. So that was my 21 minute. Sorry, I went over time, but now I'm more than interested to get questions from the audience.
Hi, thank you so much for your presentation here today. We already have questions. First, unsere Zuschauer nochmal, es darf natürlich auch weiterhin Fragen gestellt werden, auch während wir hier noch reden. So let's start out. Someone would like to know about the installation process of your solution. Like, is it a downloadable package? Is someone going to come and install it, especially in a place that's hard to reach or doesn't have much time? You mentioned a ship, for example.
Yes. So our typically when we talk about the installation, we have to distinguish the two: the cloud app and then the edge app. Cloud app typically we launch from the cloud itself, so meaning that if we host it, we launch it for you and then you activate it. But if we need to install it to your environment or a local environment, of course, then you need to have an installation script that you get from us, and then you also get installation script for the edge app, and you can install them as many as you want, and then they are like sleeping edge, and then you can activate. So the mode activate them by the license key. So that means that the most effective way is to install them everything you do, and then if you don't take them into use immediately, it doesn't cost you anything either. If we have an existing site, that means that we typically would need some kind of device where to put it, and then we would need to connection to it. So either we have to be on site or we have to take a VPN connection to install it. But it's still then a script. It can be also an image, but typically we provide the whole script so that it does automatically all the Docker layers as well.
All right. Well, that actually brings us to the next question. It's a nice lead over. How modern does my machine have to be to run your solution? But especially process industry, many of the machines are still centuries old.
Very good question. It depends what you do. We have a lot of what we call brownfield protocols available. I don't know, tens of them that we can do a lot of operations. Data collection, read and write, data set handling, and these kind of things for the very old machinery. Of course, Docker compliance, so to actually run my software requires a device which is a Docker compliant. So that means typically that you have to have at least a little bit modern Windows or a Linux. But that can be a separate device added later on, so your original machine don't need to be modern. But when it comes to the software updates, of the PLC itself, there you clearly have certain restrictions. So it's not given that very old, depends a lot of the manufacturer also, but typically I would say that if we talk about the actual PLC software updates, we are mostly talking about new fleet, to be honest. It's not very often the brownfield that we go with that. To Dockerize your local software and operate in a way that the local software does today in whatever EXE format, that can be added later on to the brownfield as well. The only limiting factor may be your 30-year-old PLC that doesn't allow to do the update operations, but everything which is related to the local data communication with the device, our protocol library should handle.
All right. Let's see. Well, if I already have a modern solution, but I want to use in different locations, say 2 different warehouses or two different fabrications, can I use the cloud app as a master for all of those?
Yes, you can. So that's the whole idea. So either you actually run one cloud app and all the things are happening in cloud or server, meaning that you only need one cloud app, but you may have limitations for that architecture, so that, for example, the data cannot leave the premise or some other reason why the local cloud app makes sense. Then you can make this master-slave structure of the tool that the local cloud app is taking the commands from the master cloud, so to say, and then operating accordingly, but still being full-blown operational software in that local network as well.
Well, that leads me actually over nicely because we are having also a question about, do you have specific use cases to show on or to find on your website, maybe?
Yes, we do. We do have. And we are also preparing to do some case videos that will be published there soon. However, when it comes to the software update pipelines, these use cases are anonymous for the reason that this is latest development for a very large company. So we have to have their permission to publish, and we have to do it without their name, and we have to do it in a restricted way. But there are some examples, for example, how you can distribute the software for your sub-suppliers. We have a multi-billion company who has sub-suppliers doing electrical cabinets, and you don't want to give them the software. So instead of that, you give them a piece of device that connects to their own cloud, their own Azure. We have nothing to do with that, just a tool. And the latest version of that particular cabinet comes from their cloud directly to the cabinet. It makes the acceptance test and sends the report back to the cloud, and then the sub-supplier is allowed to ship that cabinet further. So that kind of a case, for example, and 3 or 4 others, which is related to these update pipelines, we have in our homepage. Yes.
Well, it's nice. Well, of course, a solution that's so insistent on security, it's always hard to bring on. But it brings us to the next point. The Cyber Resilience Act has been making the rounds. Is Docker or your solutions, is it already compatible, or will there be updates?
The short answer is yes. And the long answer is that, because we don't have time for the actual long answer, I will make a semi-long answer. And the semi-long answer is that we have to remember that we are a tool, and Docker is basically a technology or ecosystem, meaning that if we talk about the full end-to-end solution, for example, I was explaining the case in the ship. Marine has a lot of certificates of its own, and that means that our tool can offer you ways to fulfill those, but we as a tool don't need to be it doesn't make sense that we would be compliant for such a thing. It's more in that way that the end result needs to be compliant with different kind of directives, and then we need to be able to provide you the tools to be that, and that just that we understand our position in the value chain. We are a tool, and yes, we are very compliant with these requirements, but it's not us that needs to be compliant in the last place. You need to be with your solution.
Of course, that's going to be a hard impact. We're already interested in seeing what happens. One final question I still have left in the pipeline. It's if I can't update my machine without an engineer on site, does it still offer value?
Sorry, may you repeat the question?
Oh, yes, it's a little harder. So if I have my machines cannot be updated without a service engineer on site.
Yeah, cannot be. Yes, yes.
Cannot be.
I just wanted to take that. Yes, I was trying to mention it also in the presentation that actually that's more typical case for us, that you cannot just update it like that. But the fact that you know what versions you have where, and that you can have sure that you have the latest version available in the device level. So I can distribute all the way to the, let's say, some memory slot in the actual device. And when the service technician goes on site, any site, anywhere, he knows that he has the latest version available in the device. He don't need to have a memory stick with him. There is no human errors. There is nothing like that. So everything can be, work for him. So the operation is much faster and it makes much less errors. So definitely this is the most typical use case, but the distribution is the real value, not really the last step of that's nice, but it's not mandatory.
All right. Yes, thank you for that answer too. So, and of course, thank you very much for being here today. Thank you for your presentation and for your answers. Und vielen Dank auch an unsere Zuhörer fürs dabei sein und mitmachen. And well, wish you all a wonderful day.
Thank you.